I'm Jim Holcomb of Associated Scaffolding, and I had the honor of being your 24th president. I'd like to welcome to the stage Mr. Brian Andrews, presenting Exploring the Heights, Innovations in Building Access. Brian is the Vice President of Engineering at B Access, where he leads a design team in developing temporary and permanent suspended scaffolding, including rigging and platform accessories. For over 20 years, Brian has helped provide permanent and temporary suspended access to structures across the country. Currently, Brian is on the SAIA Board of Directors. He's also the chair of the SAIA PI Council, co-chair of the ANSI ASC A11 committee, and sits on the ANSI A120 committee, and had time to come speak today. Come on up.
Thank you. Good afternoon, everybody. So yeah, I'm Brian Andrews, the Vice President of Engineering over at B Access. So, there's so many different challenging buildings that are out there to access. You know, as you see up here, you've got a bunch of different ones straight here from Denver. I guess the biggest question is, how do we access them, right? So there's numerous ways of providing access, and we all have knowledge in scaffolding. But the goal today is to open your mind to other possibilities, innovative ideas to access areas on the buildings or structures. There's no right answer, right, to anything, any solutions, but there are easier options out there. So as you see here, you've got a few difficult structures being accessed. Let's see here, how does this work? So you got a mast climber here with a dual, sorry, I don't have the mic on me. I'll stay here then. You've got a dual mast climber. You've got suspended scaffolding on a big column. You've got supported scaffolding accessing a big dam or a structure. You've also got a mixture of supported scaffolding down at the bottom over there and suspended scaffolding. So you can actually intermix a lot of different things in order to access different structures. So, as we all know, the most common types of scaffoldings are supported, rolling scaffold, suspended scaffold, and aerial scaffolds. But today we're going to focus on suspended scaffolding. Yeah, let's do that as well. That way I can walk around a little bit. Thank you. Yeah, you know what? I'm going to stay here. Yeah. So just so everybody knows, sorry, I'm actually battling vertigo right now. So everything's kind of moving around a little bit. So it's a little distracting, but we're going to make it work. All right, so yeah, today we're focusing on suspended scaffolding. If anybody has any questions as I'm going through, please just raise your hands. If I can see you or whatever, just ask the questions away. This is more of an informative presentation, and I want to answer any questions that you may have, okay? So, suspended scaffolds are raised and lowered by hoists, duh. They're located on a stirrup, and depending on the job site, you have a lot of different options out there, okay? You've got electrically powered hoists, you've got air, you've also got manually operated hoists. Electric ones, you know, it can range from 110 volt to 220 volt, single phase, 3-phase, lots of different options out there depending on what the job site has. But now with the evolution of the battery and how strong they're becoming, different manufacturers are offering battery-powered hoists. They're also offering batteries with an inverter, so you can use existing hoists that are in fleets that are already out there. You also have hoists on the right-hand side with built-in wire winders. All right, so it's actually collecting that wire rope so that no wire rope is hanging down below the scaffolding and potentially hitting something, electrical lines, anything like that. You've got different either powered wire winders or passive wire winders. So lots of different options there. So let's start where it all began, right? Bosun chairs and work cages. As you can see, it's evolved from a person that's just on a wooden board, right? And it's still out there. It's still perfectly fine, and people are doing that on a day-to-day basis. But it's gone from the person on the chair to, on the wooden board to a chair to now a modular little platform, right? A work cage that they can actually stand on and now actually access right there from their feet. There we go. However, when you guys think of a standard swing stage, this is what you think of, a 2-point stage. This started off with pick boards and fixed length platforms, which is right on that picture over there. But then they've evolved into modular platforms. And modular platforms, a lot of them that are out there, can span 50 feet between hoists. With a 10-foot cantilever on each end. So then it's actually making a 70-foot long platform with 2 wire ropes. It's pretty crazy. Multi-point suspended scaffolds are platforms that require more than 2 hoists. These can be straight platforms that just run forever if you really want to go, and all you have to do is just add a hoist and a hinge, and you can go forever. Or if you're trying to go around a corner, and that corner also has to be supported, otherwise it's going to start dipping downwards. So talking about corners, some manufacturers offer lots of different types. And you've got hoist-mounted corner, you've got fixed corners, you've got adjustable corners, continuous adjustable corners, and custom corners. So let's actually look at some of these a little bit more in depth. So here, is this working? There we go. So here you've got a fixed length corner. Custom corner, as you see, that looks a little bit funky, and it's very large and all that, so it's a custom corner for that specific building. You can go with adjustable corners that are up on the right-hand side, and that is able to go and change the actual angle of the corner so that it wraps around the building. You've got corners, wrong way. You've got corners here to be able to go all the way around the contours of that building, all the way around a circle, and then a very, very shallow corner to actually access that point right there on that building. So it's pretty amazing what corners can do. When you're operating numerous hoists on a platform all at the same time and you want them all to go up at one time, you can use something called a central control box, also known as a CCB. These central control boxes connect all the hoists, ranging from 2 hoists. I've seen it up to 18 hoists from one button. You hit one button and all 18 hoists go up. So the big concern there is making sure that all hoists are running at the same speed and making sure that there's not overweighting one hoist versus all the others. So that central control box actually looks at all of that to make sure that everything's operating and going up at the same time. These types of central control boxes, you have different options as well. You have electric, you have air, and you also have wireless. So lots of different options for central control boxes. One of the biggest questions, though, that I get on a day-to-day basis is accessing recessed areas. That is the #1 question. So let's really explore accessing some recessed areas. So a double-wide platform accesses about 0 to 3 feet back in underneath a overhang. The hoist is usually mounted right there in the center of the platform. A standard modular platform is 2 foot wide, so then therefore you're able to get in that 3 feet. Some manufacturers actually offer a platform that's wide open in the middle, while others stick with just having 2 platforms running parallel with each other, so you actually have to step over the mid-rail. There's not really a major advantage, weight capacity, one versus the other, but there is an advantage for people to be able to just walk over and not have an obstacle. But stair-step platforms provide access to the underside and upper edge of the building. So when you're working on an ephes, signs, or edging on the top of that building, you're able to actually access a little bit higher and underneath. So it's all in one platform. Oftentimes you're using a standard stirrup, but there are custom stirrups that need to be made to use with the stair-step type platform. Fixed or hinged porches are often used on 4-foot recessed areas. Okay, so this is also depending on the application. So if you see on the top right and in that top center, that's going to be a fixed type porch. That goes and it's for the fins or the columns that go the full height of the building. When you're trying to gain access to recessed areas on the building, such as right here or right there, you can use something called a hinging porch, where it actually folds in and out of the platform to gain access into that area. There's also a few manufacturers out there that have a newer style porch where you don't have to actually step over the mid-rail. So if you look here, you've got... Is that working? Yeah, there we go. So if you look here, you actually have the worker right here is having to step over this mid-rail bracket that actually is supporting the porch. So some manufacturers now are having some porches that are able to, you don't have anything and it's wide open to just walk straight through. So for sliding porches, this is a long porch. Ooh, okay. That goes back in about 7 feet from your suspension point. Okay, the sliding porches, a worker actually pulls a rope and the actual sliding porch moves out one direction and a counterweight goes on the opposite direction to counterbalance the tippiness of this. Then they pull another rope and the counterweight comes in with the porch all at the same time. The issue with a sliding porch is the load capacity. There's usually a low load capacity on this because they're very heavy. Another option is actually taking modular platform and creating a rectangle out of it, and then cantilevering that rectangle so now it can actually come further back in to the underhang. This can usually go up to around 7 feet. This is one of those that is fixed and has to go all the way up and down the full area of the building. These also have a very low load capacity because when you're out on that cantilever, you're putting a lot of load and strain on a lot of those different components. If you want to get a little bit further with that, you can use it in conjunction with some other rigging devices. So on the left-hand side, you see a down and under, which is a bracket that goes onto an outrigger beam. You'll see it later. Where it actually brings you back in underneath that overhang a little bit more, and now you can gain in a little bit further area back in. So in that instance, it's actually 10 feet. Dance floors are usually used to gain access to very, very large areas. Dance floors also, you usually have rigging from underneath the overhang. So in this instance, on right here and over there, you'll see pigeonholes. Those are holes that are inside the actual building structure itself that the wire rope comes through and supports the suspended scaffold on at least one side. And then on the other side, you can either have more pigeonholes or have rigging from up top that you're rigging from to now provide access for this full area. You can have access on the outside of a building or even inside. So if you're doing atrium access, anything like that, you can use a dance floor, and you have the full surface area on that whole area to walk around. Load capacities on dance floors is actually very dependent on the number of hoists. So the more hoists that you have, the higher the load capacity. Another one is actually using custom equipment. So most of the time, this type of equipment is used on permanently installed platforms and rigging, but this is where the actual hoists that you see right there in the center are actually picking up the platform and a counterweighted system on the backhand side. Depending on the location of that counterweighted system, it actually pushes the platform back into the building. You'll actually see a picture of one of these on a BMU later on. Providing access to balconies. So around a U-shape balcony or something like that, you've got platforms where you've got a 90 and it actually creates a full U. Right here, over and back, here, over and back. You can also do a platform where it's a straight platform and go outside, be able to lift up the platform as you see on this area here. You're lifting up the platform from some davits, rolling the platform out, and then coming back down the length of the building. If you need to get access back into that recessed area, you can use a porch, fixed porch in this instance, or even a hinging porch if you really would like. When you have platforms that can extend in and out, you can use this type of thing. It's a telescopic end section or wing where that platform itself extends in and out where you can gain access into that balcony. A lot of times they're used on balconies or even like crane tie-ins or something like that so you can get around that tie-in. Multi-tier platforms can be used when installing long panels, siding, windows, or you're just needing access at different heights on a building all at the same time. You have two different styles. You have it where it's actually a fixed or adjustable height. So the adjustable would be used with wired ropes to actually provide the distance in between your platforms, or ladders, so that now all of a sudden the personnel can walk from one level to another level and have access all the way through. When you're using multi-tier systems, the personnel up top are not required to be on a horizontal fall restraint system. The people on the lower level have to be. So then therefore it's actually going to be considered a 4-line system where it's 2 wire ropes per hoists. Another option is inclined or angled access. So when you're on something like a dam, a pyramid, just any type of inclined surface, this type of stirrup would be used. One thing to really note, though, is the actual rollers, right? So the rollers are very, very crucial when using inclined stirrups because of what they're actually rolling up on. If they're on windows, then you want something that's going to be dispersing the load more. If it's more on structure like a concrete structure, it doesn't have to be. So you can see really a lot of different roller styles here, here, and there on these platforms for the different applications. Under bridge access. So when you're actually trying to get underneath the bridge, there's lots of different options here as well. So you can have a fixed type platform where it's just fixed in one section and it runs the full length, something like up top here and up top there. Or you can have it where it's actually on a roller system and the whole thing is actually going the full length of the bridge. Sometimes you can even have it where it's suspended on hoists. So it's able to go up and down. As you see here, you have a little bit of an archway on that bridge. So now all of a sudden, as you go one direction or the other, you actually have to raise up that platform. So you can have hoists on that whole system to be able to come up and down. Access to the platform is usually used with supported scaffold. Cable access on a bridge. So there's two really different styles that different manufacturers offer for this type of system. One is a fixed platform where it just rides the length of the cable itself. And then there's another one where there's a cart that goes and rides the cable up top, and then the platform goes and suspends from that cart. So you're able to gain access up and down the full length. There's also high capacity platforms. So there's lots of different types of these out there on the market, from very similar to the deck, that stationary deck on the bridge that you just saw, to using system scaffold and using some special stirrups on that and suspending the system scaffold to be able to go up and down. Another one is actually custom-made high-capacity platforms that are out there that go and create dance floors or even just a straight platform. So depending on what the application is, what's really needed, lots of different options out there for access. The biggest issue that suspended scaffold has is you have two hoists or three hoists on the platform, and you're trying to lift up all this material, all the platform itself, and everything. So the lower the weight of that platform, the better, so then you can actually get more material on, so you can get more work done. So what manufacturers are doing is they're creating new types of stirrups, new equipment for the platform, accessories, all the above, and they're making them out of aluminum and lighter weight stuff. So that now, as you see here, you've got aluminum stirrup, you've got aluminum bumpers. This is another aluminum stirrup out there. So lots of different stuff to reduce the weights so that then people have higher load capacities on the platforms. You also have windmill and tower access. So blade maintenance, blade inspection, tower access, all these different things. You can use modular platforms with a lot of different accessories out there, or you can have custom platforms built specifically for going around the blade itself, as you see right here. And actually you can see it right here through the top of the turbine. Another form of access, elevator access. So these are called false car systems, where you actually mount a rail system inside the elevator shaft, and the false car goes up and down along those rail systems. They're often used with very high capacity hoists that run at different type of speeds than the standard suspended scaffold hoists that are out there. Custom platforms. Now's when we're getting into the fun stuff, in my eyes. So on the left-hand side there, you have something called an extended cantilever, where the rigging can't get all the way near the end of the platform. This is a 15-foot cantilever beyond the actual suspension point of your hoist. A lot of times this is with mansard beams, or there's obstructions, something like that, that's on the building right at the rooftop where your normal rigging would be, and you just can't get out there. The next one, top right, is something called a stair step platform. So this is really on roofs that are at an angled surface. So you have rigging here and here, and you're trying to go up, so now you're able to actually go up the platform and have access to that entire angle. And then also you have custom platforms where you can't get a barge underneath, and there's a waterway or something like that, and you can't get a barge to actually bring your platform in place. So manufacturers create floating devices to actually go and keep that whole platform, that big dance floor, floating. You bring it into position and then lift it up. You also have circular platforms right here in the center, where it's going around a specific diameter or something like that you're trying to get around. You have on the left-hand side something called an umbrella platform, where it's actually going down through a hole and then opens up. So you're going through a X diameter hole, and then it needs to get bigger, so then you can gain access on the outside. And then last but not least, on the right-hand side, you've got something called a digester platform, where you have the open center. And then in this one instance, there were some custom features that were also inside this shaft that we had to create different cutouts within the platform to gain access and go up and down. Creating a V section. So when you have a really, really tight area where in this instance it was a dam, you had two areas that you had to actually come into the middle of and gain access right there in that center, creating a special custom area to have the modular platforms on either side, and then you have the custom section right there in the center. You also have an inclined platform that goes into a shaft, and so you have the hoists that are mounted up on the rooftop. You have wire winders, and then you have a pendant that went and operated those hoists to raise and lower the platform. So how are all these platforms being suspended? Well, it's called rigging. And your standard rigging equipment out there is right here. And a lot of people here, I'm sure, know all of this equipment. You know, you have your outrigger beams. They started with a steel box beam. A lot of people know that terminology. But now most are out there with aluminum. And it's either I-beams or rectangular type beams. The designs are actually going out to be close to 15 foot in outreach now. It's pretty crazy how far they've come. You also have parapet clamps that are on the bottom left. Then in the center, something called a tripod stand. And then on the right-hand side, EFIS hooks. But now what's happening is manufacturers are accessorizing those standard equipments. So now what we're able to do is create custom pieces that go and attach to all those components that you already have. So on the left-hand side, you have something called a down and under. So that gets the rigging point to be underneath where your actual support is located. You have on the right-hand side in center pictures something called a post shore adapter, where instead of having to lug up 50-pound counterweights to the rooftop and support and counterweight the outrigger beams, you use a post shore, and that goes and applies the load into the structure on the backhand side. You can also put the outrigger beams right on top of scaffolding. And you use a header beam or something like that goes and actually can support the load on the scaffolding. You have beam clamps, and now you're able to get the beam up higher to either roof launch a platform, get over tall curtain walls, large parapet clamps, or even spanning big difference, like if there's a pool in the way or something like that. On the right-hand side, you have something called mansard beams brackets, where if you have a sloped roof and now you're trying to gain access down below and not wanting to have a massive outreach, you can use a mansard beam bracket. Monorails. Monorails are getting bigger and bigger by the day, and we're hearing a lot more people are wanting these. So let's talk about them a little bit. So you've got a little bit of time to set these up because there's a lot of rigging involved. But once they're all set up, then all of a sudden the platform can come up and go anywhere along this building that it needs to gain access and just roll into position. You also have dual monorails. So right here in the center, where you have the capacity of a material hoist and the platform all off of the same rigging area. You can go and raise up a window, for example, into position, and the workers on the platform itself can set that window into place. You can go around corners. On the top right, you see that. You can support beams from parapet clamps or lots of other rigging devices that are out there. And then last but not least is permanently installed monorails. So that bottom left picture is a permanently installed monorail that's fixed. It's attached to the building structure, and it stays there, so now you can have access that way. Then we get into some custom and specialty rigging. So on the left-hand side here, you see a lot of beams that are on that structure. What is actually happening in this one is there's some beams that are laid down, and then they are used as your support structure for the standard rigging. So instead of having to have counterweights up there, they're actually tying down to those beams. On the middle picture, you have a fixed mast with outrigger beams that are on scaffolding. So you can kind of see the scaffolding over here and a mast that's all right here. Mast and your outrigger scaffolding there. So you can kind of intermix a lot of these different things out there. A lot of scaffolding, supported scaffolding, masts, all the above, and intermix with suspended scaffolding. And on the far right picture here, you have beams on scaffolding that's on a sloped roof. So making sure that that whole beam setup doesn't slide off the roof. You know, you have to do some specialty stuff there to prevent that. On the left is a hodgepodge, as you can see. There are lots and lots of equipment on this corner of the building. You've got 2 double-wide platforms. You've got powered wire winders on the rooftop. You've got a wireless CCB so that the operators on the actual platform can go and raise and lower themselves. You've got a monorail system with a turn in it to pick up a material and bring it into position. On the right-hand side, you've got supported scaffolding and a suspended scaffold. So what's actually happening here is the supported scaffolding is supporting the rigging outrigger beams, and the suspended scaffold is coming right off of that. So it's accessing above with the supported, accessing below with the suspended. Now let's get into some permanent rigging. So this is permanently installed outrigger beams. So it's very, very, very similar to the standard outrigger beams that's used in temporary access, but these are just tied straight down to an anchor, so no counterweights. You also have options of a back-fed outrigger. So that in this instance, here and there, that outrigger beam is attached straight into the structure of the building. You're able to feed the wire rope straight through that beam, and wire rope just comes over the edge. A lot of times that's used on an unprotected edge of the building. So now if you can't have access over to that edge, you're able to use the back-fed outrigger. Push-out outriggers. So these are very, very similar to the back-fed outrigger. The push-out outrigger are beams that slide through a hole that's in the building. And oftentimes, these type of setups, there's a little flap that's on the top of that hole to prevent birds from being able to come into the attic or whatever is on that building itself and create a nest right in there. Davits. So davits are on a lot of different rooftops, right around here actually that I've seen. And you have 2 different types of davits. You have a top rotating davit and a bottom rotating davit. Your top rotating davits are for roof launching a platform. And when I call roof launching, the platform is actually on the roof itself. It's assembled here. It lifts up and then comes out and goes down the side of the building. The bottom rotating davits are for ground launching. So that's where the platform itself is assembled on the ground and then is raised up from there. Now, one thing to note that a lot of people don't realize is you can have a mixture of permanently installed equipment and temporary equipment on a building. So here you can see permanently installed davits with temporary platform. Right here in the center is permanent platforms as well. So you can have a mixture of all this different equipment on buildings. You also have things called roof carriages. So these are davits or a carriage system. Carriage system is on the right-hand side, where these are rolling on a track. And if it's davits, once again, you can use it with temporary or permanent platforms. Usually, though, when you have the standalone carriage, those are used integrated with a permanent platform, because you're actually able to operate the carriage and the platform usually from the same location. And last but not least, we have BMUs, building maintenance units. And I love to say these are the Cadillacs of the permanently installed industry because they are massive. They're very, very large systems with huge outreaches, but they are able to do a lot of things and provide access where a lot of other type of rigging is just not possible. So this is actually, in this picture, is that counterweighted system that you saw originally for the overhang. So the suspended access industry has come a long way, but with the help of engineering, we are continuing to invent new safe solutions to accessing buildings that architects are dreaming up of. Thank you for your time. If you guys have any questions, please feel free. I'm here. So are there any questions? One back there.
So for the swing stage with the massive canopy on the side, typically swing stage has a little bit like 2 workers per channel. You have to get very specific, like only 1 worker on the cantilever.
Yes, sir. Usually what happens is when there are those massive cantilevers, that's more of a custom type platform, and you usually have one person that's able to go out there, so it's a 250-pound capacity. You also usually have to have a backspan. So that platform can't just have a massive cantilever and a very short section here. So usually you have to have a good span back to counterbalance that cantilever. Sometimes, though, when you don't have that, then some manufacturers will go and actually put counterweight on the backhand side of the platform itself, securing the counterweight to the actual platform so it can't shift, it can't move around, and now it's counterbalancing that whole system. Rick?
The one picture you showed where you had wire winders and the hoist mounted on the outer beams, what was the reason for on the hello? Okay, I'll talk to the cube. On that, the picture you showed where you had wire winders and hoists on top of the beam, why was that option utilized rather than the more typical method of having the hoist on the platform itself?
Okay, so there's two different options for that. So if you're picking up material, you can have and collect all that wire rope right there on the rooftop. So then you're not actually trying to have your actual weight or that material that you're picking up and your wire rope going and potentially getting tangled up in that. If you're looking at the suspended scaffold side of it, usually what you're doing is if you're trying to prevent wire rope from being collected, or I'm sorry, prevent wire rope from being able to swing around on down below the platform, so below the hoists. We talked about the powered wire winders to collect that wire rope. Well, the taller the buildings, the more weight is going to be collected on that platform. So sometimes you can't do that. So what you do is you actually put the hoist and the wire winder up on the rooftop so that then it just comes straight down to the actual platform. You're not collecting any wire rope. You're not adding all this extra weight to the system, and it works a lot better. Did I answer your question? Yes. Perfect. You can control those with wireless remotes. Yes, sir. Or you can do long pendants as well.
On the newer battery style platforms, how much extra weight does that add to the platform?
Depends on each manufacturer. I'm sorry. So the question was, how much weight with the new battery-powered systems does the battery and everything add to the platform weight? It really depends on the manufacturer. It depends on the batteries being used. So that's kind of a question I can't answer. Sorry. Any other questions?
So you had mentioned the use of lighter materials.
Mm-hmm.
Aluminum being one of them, or any others on the horizon?
So we have seen some, sorry, the question was, we had talked about lighter weight materials being used to lower the weights that's of platforms. And is there any other components that are being used out there for the design of equipment or anything like that? And we have seen out on the market actually carbon fiber davits that are out there. We've seen some other like titanium I've seen out, but usually the cost versus what you're getting back from it isn't usually the best thing. So aluminum is more or less the standard. Any other questions? Yes. So he's asking about using lightweight material with cold weather and everything like that. Yeah, sometimes your material does get brittle in lighter or in colder weather. So you do definitely have to take that into consideration where that platform is going to be used, all the above for that. Any other questions? All right, well, thank you very much.